IFC is this internationally standard language for our industry. It's effectively the HTML of how buildings should be described. We should be developing our digital buildings and describing them to the computer natively using this HTML, this IFC language. That's how BlenderBIM really started taking off.
Hi, welcome to another UH Studio Architecture podcast. And in this podcast episode, we're joined by Dion Moult, who's the developer behind BlenderBIM. Dion goes into detail about what BlenderBIM is, how it can help architects, and its usage beyond architecture design in the wider AEC industry. This is definitely an episode you want to check out because BlenderBIM, with its native IFC authoring capabilities, is perhaps the tool of the future of architectural design, and of course it's completely free and open source. And make sure you stay for part 2 of this episode where Dion takes us through designing something simple with BlenderBIM. So if you happen to be listening to this on your preferred podcast platform, check out youtube.com/UHstudio for the video tutorial as the part 2. So let's jump into it. Dion, very nice to have you again here. How are you?
So I'm just agreeing with you. Very nice to be here. Very nice to be here. The audio is working perfectly this time around. Hopefully people can hear what we were saying this time.
You have initiated the development of BlenderBIM. Can you summarize that for us a little bit? What is BlenderBIM and how do people use it?
Yeah, absolutely. So I guess in a few sentences, the BlenderBIM add-on, that's the full name because it's an add-on to Blender, is a native IFC authoring platform. So it lets you do, the end goal is that you can do everything you need for the design, engineering, and the construction of and the operations of the built environment. So this includes drafting, modeling, doing energy analysis, structural analysis, creating drawings, asset registers, live building sensors, construction scheduling, cost planning, like every single task in the AEC industry is what we're tackling, is that you can do it all using a native IFC approach from beginning until end.
Right, so it aims to be a complete open source BIM solution?
Absolutely, yes, and it wouldn't be an appropriate BIM solution if it didn't go across all the disciplines. That's the whole point of BIM, that it is cross-disciplinary, and the data can integrate. So absolutely. Now, some of it is highly specific to Blender, and Blender is a 3D modeling application. So you can just like in Hollywood, right? You create 3D environments and you can create pictures and so on. But of course, not all of the built environment is a graphical task. In fact, a lot of the data in the built environment is not a graphical task. So there's actually a lot of BlenderBIM's the BlenderBIM add-ons engine that can be used outside Blender in a very non-geometric way. So, but yes, indeed, we are tackling the whole end-to-end workflow.
So non-geometric ways, do you mean tables of data? And
yeah, absolutely. So I'll give you a few examples, like cost scheduling. A great way to absorb cost scheduling data is in a spreadsheet format. That's a way with that's the way which clicks for people. A great way of absorbing time or construction scheduling data is in a Gantt chart form. And those types of relationships they are not geometric relationships. It's project planning. And then there's asset management, lists of manufacturers and suppliers and warrantors and associations with who to call where your inventories are. That's all non-geometric. So I guess, although there is a nice, flashy, beautiful aspect of it, which is very, very geometry heavy, a lot of BIM that we are also tackling is also on the non-geometry side.
And how do the two talk to each other? Like, can you export an Excel sheet, edit it in Excel, and then plug it back into BlenderBIM, for example?
Absolutely, and I guess you wouldn't really use the word plug it back in BlenderBIM. It is still the BlenderBIM add-on. I guess this is where there's a bit of a confusion in the marketing terms there. So
Yeah.
maybe I should peel it back a layer and talk about IFC OpenShell. And IFC OpenShell is a IFC library that was an ecosystem of tools that was developed, I think, over a decade ago now. And um, that and what IFC is a industry standard of how the data in our digital built environment should look and how it should be structured. For example, when you say I have a wall, well, what's the definition of a wall? And there's a little ISO standardized sentence which says here's a wall, and it says a wall can have these relationships with A, B, C, D. A wall can be in a room, a wall can have a quantity, that quantity can be referenced in a cost schedule, and so on. And IC OpenShell provides a suite of ways of manipulating these objects and their relationships to other BIM objects that are compliant with this internationally standardized BIM standard called IFC. And one way of manipulating or viewing that data would be in a graphical environment like in Blender, but there will be many ways of viewing that data. You can equally open an IFC in a spreadsheet as long as you and edit things which make sense in a spreadsheet
Mhm.
and save that data back in the spreadsheet. Just like, I guess, if you think of GIS, in GIS, there are some things you can view on a map spatially, and there's some things you can view in a spreadsheet form. Same thing in IFC,
Okay.
right? You can view
So
some things spreadsheet wise and some things geometric wise.
so it's a bit like OBJ or FBX formats as well, which are text formats essentially. You can open them in your text editor and view the information and edit it if you know what you're doing.
Yeah, that's right. There are many ways of representing the same data,
Yeah.
and you can open it in different ways, and it's still the same data at the end of the day. And certain representations are more suited towards certain tasks. And one very popular representation, of course, is the sexy 3D model that you see, with all the colors and the relationships and the built form and the properties. So that's where the Blender BIM add-on comes
I'm
in. It gives you
salivating
that
here, Dion.
graphical environment. Well, that's right. That gives you that built environment, that graphical environment to go and draw your walls out and do all that type of fun stuff.
And so what's the relationship between Blender BIM and IFC OpenShell? Are they one and the same, or is one part of the other?
Well, I guess the relationship is a little bit historic. So long before the Blender BIM add-on started, IFC OpenShell had a little Blender add-on known as IFC Blender, and that allowed you to import IFC data into Blender. And I use the word import because it translated IFC data into Blender data using the Blender geometry structures and the Blender data structures and so on, just like an import-export tool that you have in
Hmm.
other software. And
Which is
the
typically how IFCs get moved around, right? You use one software, let's say
correct.
Revit, you export your IFC, somebody opens it in Navisworks or something else, and then
Yeah,
they
they
export
import it
it.
again. Yes, that's right. And this is what I like to call the translated OpenBIM approach. It's one step ahead of the traditional BIM approach, which is purely this platform only speaks to itself and nothing else.
Hmm.
Revit speaks to Revit, ArchiCAD speaks to ArchiCAD, and that's it. And then you have the translated OpenBIM approach, which are where you have an intermediary open specification. And one approach is to use IFC as this translated OpenBIM. You export to IFC, then you import back into whatever tool you use. Another example is Speckle, for example, right? You export
Yeah.
into the little bit into Speckle, you import back into the other thing. But there's a problem with the import-export approach, and that's that there's a translation loss, right? It is a translation of one data from another. You'll never capture the full breadth of data, and sometimes that's okay. Sometimes just to get your workflow across. It's great just to transfer that little bit you need and transfer it back in from A to B, and that's fine. However, increasingly, we're finding in our industry that that's not good enough. We have very rich relationships that are being lost. And also, they're very fundamental relationships, which shouldn't need to be translated at all. You should just have a industry standard way of defining it. Like, what's a wall? Oh, well, this is a wall. Well, what's the fire rating of a wall? Well, in this property here is the fire rating of a wall, because that's the industry standard way of doing it. Right? If you ask 15 architects, where do I find the fire rating of your wall? If they're using the first approach, this traditional BIM, you'll get 15 different answers, right? It depends on whatever they had for lunch that day and where they decide to put their property in their different program. You'd have to, on each project,
Pretty
look around.
much.
It's probably in a property called fire rating somewhere, but you have to dig for it, and you'll need
But
the
then
right
also,
software.
in like a typical Revit environment in large companies, large companies make their own libraries of doors and windows and so on.
Exactly.
And they put their own kind of version of specs. So maybe there's a standard like Revit, which translates directly to IFC, but then some, go and create their own fire rating or whatever other property exists out there.
Exactly. So there's really no structure to it all. It's like everybody has a spreadsheet template, and you're all inserting your own rows and columns and formulas willy-nilly, and it's a bit of a mess, really.
I suppose in those traditional formats, what's important is that there's kind of automated tagging tools, right? So you can use those tagging tools to tag with whatever property you need. So if your fire rating is not exactly, fire rating per whatever spec, but you still find it, then it makes it easy to tag whatever elements you have.
Absolutely. Yeah, and that's perfectly fine if you're only using BIM as a means to an end, and if you're
Yeah,
only using BIM internally, like just your company or just your department or just your project, and you're not thinking about wide, uh, industry-wide uses, other users across different platforms, other countries, internationally, being part of a big digital city. It falls down a little bit, and I guess this
for
whole
sure.
translated open BIM is a stepping stone away from traditional BIM, in that maybe 6 times out of 10 your fire rating goes in the right spot. Maybe 6 is a bit optimistic, depending on the user or where you are in the world, and the maturity, the digital maturity of your little, I guess, local industry. But yeah, it's a little bit better. And what we're saying is that IFC is this internationally standard language for our industry. It's effectively the HTML of how buildings should be described. And we should be developing our digital buildings and describing them to the computer natively using this HTML, this IFC language. That's how BlenderBIM really started taking off. BlenderBIM started as this parallel to this import tool that existed, a little export tool. We had import but no export. So we started as an export tool, but as we started building this export tool, it started feeling not quite right. There's only so much you can export, and you get huge projects, and then you sit and wait while it translates the entire project down to this thing, which anyway half the thing is lost and mistranslated anyway. it's it's a futile exercise, really. But we did it. We delivered a project purely using IFC, a small internal project at the company I work for. And that was what started the BlenderBIM add-on. But what made it take off is when we said, hey, why not we just work with IFC natively? And it became I think it's the industry's leading native IFC platform. I don't think there is anything quite like it in the industry, and it's been a little bit of a trailblazer and has led to a lot of new platforms or older platforms adopting this approach. I think now you're seeing little IFC editing tools from that are out there in the industry that didn't exist so many years ago. Like in an IFC viewer, in some proprietary software, I won't name names, you can actually start editing attributes or properties, or you can do
Hmm.
little spreadsheet imports or exports, or I will name names for this open source ones, like IFC.js, for example. You can start coding it with very little knowledge on the web, you can start building IFC data. Um, so I'd like to think that that's the kind of evolution that BlenderBIM had. It started off originally as a little import script, and then an export script got added, and then we scrapped it and then started again with this native IFC approach.
So yeah, just to describe the audience a little bit of what Dion is saying is basically you open an IFC and it opens as a native file. There's no import, there's no time. It's very fast. It's ridiculously fast. I guess it's because we're seeing a representation of an IFC element. Is that right? Like, is the geometry still handled by Blender, or how does that? No,
No,
everything is handled by us. So what about the meshing?
so I guess at the end of the day, whenever you want to visualize something on a computer, you tessellate it, right? You get a bunch of
Yes.
triangles. No matter how the geometry is described, at the end of the day, you're working with triangles. And what it's actually this. It's interesting to describe the open IFC process in the BlenderBIM add-on. What happens is actually very little, and you can read all the lines of code. The only thing it really does is tessellate geometry so that you can view it on the screen. But that's merely a representation of it. And a way I like to describe it is like, in CAD software, you draw a perfect circle. You know it's a perfect circle. But if you kind of zoom into it, you see the facets. You see it's not
Yeah.
actually drawn as and that's because that's how computers work. It's the same. In IC, you'd zoom in and you'd see the facets in this, and it's a mesh, right? It looks like a mesh. It is a mesh. It's a Blender mesh. But it knows under the hood that it's actually a whatever. It could be a B-rep, it could be a tessellation, it could be an extruded solid, it could be a bunch of Boolean constructive geometry. It knows what it has underneath. And the BlenderBIM, and this is actually one of the biggest things about IFC that makes it unique and makes what BlenderBIM does very special, in that our industry is not like the CG industry. It's not like the games industry. The CG industry and the games industry work in primarily a mesh-based world, and I guess you get voxels for certain types of games. All right, but simply speaking, everything at the end of the day comes down to a mesh. Um, Whereas our industry doesn't just work in meshes. Meshes are appropriate for certain things and less appropriate for other things. For example, we deal with a lot of solid extrusions, which are necessary for precision or describing the design intent that this is actually a profile which is extruded that way. We deal with perfect circles, of course. Meshes doesn't have a perfect circle. We deal with parametric profiles. We know that an I-beam has a certain number of parameters that's the same everywhere around the world, no matter where you are, and it's just those exact 5 parameters that define the shape of an I-beam. And so there are many geometry paradigms ranging from the explicit, like meshes, to the implicit, like these parametric definitions. And the BlenderBIM add-on knows the underlying representation and gives you the appropriate tools to edit that representation. If it's a mesh, if it's mesh-like, you can edit it like a mesh. If it's a extrusion, it actually stops you in the latest. It stops you from editing it as a mesh, and it gives you extrusion-based tools. Changing the vector of the extrusion or the magnitude of the extrusion, or just editing the profile, for example. Things like that.
That's very interesting. So, do these parametric? So, first off, there's basically you're saying that IFC files work as solids, as BREPs. Is that right?
There's a variety of geometric
Okay.
paradigms. There's even point clouds in IFC.
Yeah, interesting. And then there's parametric relationships that define elements inside of it. Like an extrusion, you define by a height and by a line, I assume, and a width or something like that, or
Yeah, that's right. So you get some very simple parametric data. For example, an I-beam has X parameters. an I-beam profile is X parameters. An
Mm-hmm.
extrusion consists of a magnitude plus a vector. So that's a simple one. And then you get more complicated ones. Like, for example, if I have an extruded wall, it also knows it's connected at an end or at a start or somewhere along its path. And therefore, there should be a clip as the wall joins with another wall, or the wall should extend to meet another wall. So there's a kind of a clipping parametric behavior there. Or you get for convenience, there are actually some simple door and window parametrics saying here's a pretty stock standard window lining and panel and door lining and door panel setup, which has, I don't know, 10, 20 parameters or something associated with it. So
And do
yeah,
those nested elements, like doors and windows, do they maintain a parametric relationship to whatever they're placed inside, like a wall?
yeah, absolutely. So I mean, all those, and that's what IFC is so good at. It's so good at describing these rich semantic information. It knows not only, it's not just saying I'm tagged as a wall and my XY coordinate is here. No, no, that's very, I mean, that's your basics. You hope you've got that. It knows that it's tagged as a window. Its coordinate is here. It is a window which is filling a hole which is cut out of the wall. It knows that therefore the hole receives a certain fire rating property, which is indicated by the opening of the wall, for example, and it knows that that opening is therefore placed in a wall, and if you move the wall, you can choose either to move its children with it or without it, for example, or it knows that the opening should move with the window because the window is filling the opening, that type of thing. It knows those types of relationships.
That's excellent. You described a lot of parametric relationships that I ever thought existed. I always thought, you have a door or door assembly rather, and you put it inside of this wall assembly. And how does uh, Blender BIM handle, let's say, more complex geometry? Can you plug in geometry directly from Blender and tag it as IFC? And is there a way to look into generating curtain wall systems, for example?
Yeah, absolutely. So I guess so. There's a few ways to answer that question. I guess the first is if you create a mesh in Blender, because that's what Blender is, a mesh modeling tool.
Yeah.
Any mesh you create can be turned into an IFC object. Um, and sorry, just a fun fact here: IFC objects don't actually need to have any geometry at all. They can be just an object that exists with no coordinates, no nothing, and that's perfectly fine. But if you did want to give it geometry, you could give it mesh geometry. That's one of your options. And because Blender is a mesh-based tool, off you go. It's very straightforward. You just say assign and done. Now, if you want to create solid geometry, so Blender, of course, is not a solid modeling tool, but
Hmm.
the BlenderBIM add-on gives you solid modeling tools inside Blender. So hurrah, you can actually do that as well. You can create profiles and extrusions and do that. So those are simple profiles and simple extrusions, and we're continuously working on more tools so that you can do more advanced type of solid modeling within Blender. At the moment, if the tool doesn't exist, you have a choice either to leave it as is, or you can always, I guess, cast it into a tessellation because meshes are the lowest common denominator. Like everything can be expressed as a mesh. Um,
Yeah.
so you always have that choice. But of course, there's a warning, right? It doesn't do that randomly and corrupt your data. You have to make the choice saying, in this case, yes, I accept the fact that this shall be represented as a mesh. And sometimes that's what you want. Anyway, but I guess something you were alluding to in your question was complex parametric stuff like a stair, right? Stairs are really fun. Um,
Yeah.
there's everybody
Or
has tried
curtain
to create
walls.
this. Yeah, or curtain walls is another
Yeah.
really fun one. And I think the answer is that this is actually out of scope of IFC. And when I say IFC is the HTML of our industry, I really do mean it like that. The point of an ISO standard isn't to go and stuff in every bell and whistle that every private company comes up with, because there's 100 ways, there's so many ways to slice and dice a curtain wall, right? IFC has made a choice that certain things are standardized and other things are not. So, for example, and so IFC 2x3 actually had the concept known as the standard case elements. So you'd have the standard wall, and a standard wall would be an extruded profile, like a prism, and just that's a box, it's a wall, and that handles a good 90% of your walls out of there, right? Sure, there
Yeah.
are a couple of funky walls out there, but maybe more than 95% of the walls are covered by that. Now, unfortunately, it's very difficult to come up with a definition that works for 90% of curtain walls. Maybe one day we'll come up with that as an industry. Who knows? As we, especially now, we're moving towards increasingly modular construction to try and creating kit-up parts to try and be more economic with our limited resources on this planet. But at the moment, that's out of scope of IFC. But it doesn't mean it can't be done. It simply means that the method of generating that geometry is not part of the IFC spec. So
Okay.
therefore,
Yeah.
not any IFC viewer would be able to deconstruct the parametric relationships. They'll still view it. They just can't deconstruct it. Um, so you'll just need to go to, I guess, another platform which does have the know-how of how to deconstruct that. It's a bit like, let's say you do some visual node programming to generate, funky stair XYZ. Um, anyone can view it, but they'll need to have your visual node set up if they want to go and manipulate it. Same thing.
That's a good way to describe it, I suppose. So, in IFC, if you're generating a stair, if it's a masonry stair, you have your masonry. So you have the profile and the volume, the surface area, and so on that it takes. And then you have some finishes that are on top, on the sides, the parapet, which is a different material, and so on. I suppose we can say the same for a curtain wall, right? Essentially, a curtain wall is generated by mullions, which are profiles, right? Sometimes those mullions are the structure, sometimes there's another level of structure, and there we have the glazing panels. And those are either like, as you said, thinking of it in construction terms, it's a panel, and that panel comes with its own frame and glazing, right? And we know that we have a certain type of panel A, certain type of panel B, and so on. So I suppose in that sense, if you generate, let's say, a curtain wall in this case, somewhere else, and then you bring it into Blender BIM, um, how would you tag it? Like
I
if you
don't think it would
if
affect tagging in any way, so long as they've
okay.
got the necessary semantics. Don't confuse a generation of geometry with the availability of the semantics. So it will still know it's a mullion. It will still know it's a glazed panel. It will still know it's a curtain wall. It would still know it has certain quantities, or you can count them, or decomposed in a particular way, and so on.
Now, SphereChalk, which is a plugin for Blender as well, an add-on for Blender that is similar to Grasshopper with node-based scripting. I know they also have brought in solids modeling. Does Blender BIM somehow speak to SphereChalk and vice versa, or can you generate something in SphereChalk and bring it into Blender BIM that's solid-based?
I'm going to say yes and no. Yes, you can. No, it's not stable yet. So if
Okay.
you have if you like testing out unstable stuff, go for it and do it. So the way we do it in the Blender BIM add-on is we say you can, if you want to, you can connect your geometry generator to platform ABC. So you can say, hey, by the way, this object should always have its geometry generated by Sverjak. And then you can create whatever node setup you want, as long as at the end of it you have a certain set of outputs that it's expecting. Your vertices and edges and faces for Sverjak. So at the moment that's kind of your baseline Sverjak support. We don't yet support output in the form of those solids. It would be cool if we did, and there's nothing stopping us. Just more development time, I guess.
Yeah. And then how about the different workflow? Let's say I'm generating some Rhino geometry and some complex solids geometry, and then I want to tag that in Blender BIM as IFC. What would it be similar to what you just described in that case?
Yeah, so I guess we need to, if you tag it in IFC in the um, in the platform, it's in Rhino or Grasshopper. So you use,
Yeah.
for example, Geometry Gym's tools, for example. Then you would be able to preserve the way that preserve the geometry in such and such a way that Geometry Gym allows you to do so, because it is still an export tool, right? You're not actually writing IC directly.
Yeah.
You're exporting the Rhino geometry, and you kind of hope that if you build it a certain way, again, this is the translation problem. You hope that if you build it a certain way, it comes through a certain way. Um, I guess if you want to do that in Blender, again, we need an adapter which spoke to the Rhino geometry data structures, and again provided that conversion. But I don't think we'd be doing anything better than what Geometry Gym has already done, because he lives and breathes that platform. Um,
Yeah. Well,
but that's
it is
different, right? That's
great, but it's paid, right? So all like Rhino is a paid software, and all the IFC solutions that I know of, maybe there's some free ones, are also paid. So we have Geometry Gym, and then we have Visual ARQ, which is kind of trying to BIMify the environment, and you can export IFCs with it. Or so maybe it's for maybe Speckle could be like the best way to bring in some geometry, like pure.
sure. You'd probably still lose quite. Again, it doesn't matter whether you're going through Speckle or this plugin or that plugin. It's all the same approach, right? It's all a import export. It's all this translated open BIM. I guess it would be so much different if you could just build it directly in IFC itself. Why translate? And that's actually, we have there's an IFC Sverjak add-in, um, which is making some progress into that. It's letting you build up that geometry directly in IFC. For those of you who do programming, text-based programming, not visual node programming, um, we have libraries which let you, in a pretty high level, create native IFC geometry. So you can literally write a line saying create a circle and extrude it. Done. Right? It's pretty cool. So in fact, that's how we generate the asset libraries that we bundle with the BlenderBIM add-on. We have a shape builder utility essentially. But yeah, I guess that's the way forward, I believe.
Yeah, I guess I'm mentioning that example because a lot of people that are a bit more tech savvy in the architecture and design industry these days already use Rhino and Grasshopper. And now they're also starting to bring that inside of Revit with Rhino inside of Revit, right? Which kind of makes that process a little bit more seamless than what it used to be, which was a nightmare. Now, thanks to the McNeil guys, it's getting a little bit easier. So now I'm also thinking, okay, if people are already familiar with like one package of a way to generate more complex geometry, is there a way for them to utilize that within a more open BIM environment?
Yeah, look, I think at the end of the day, as long as you can get somewhat clean geometry, and and look, 90% of the geometry we have in in the built environment are two types of things. Either it's an extrusion or it's a mesh. That's as simple as it gets. So as long as, however you generate geometry, you can pass it off as one of those two or a combination of those two.
Yeah.
Um, yeah, we can.
Maybe a third one, a sweep, but that's almost like an extrusion in a way, isn't it?
It's an extrusion. Yeah, just the path it extrudes along happens to be curved.
Yeah.
Um, yeah, so the majority can be expressed in those manners. So it doesn't matter how you generate it to begin with. Um, I'd say sooner or later it'll be pretty easy to use whatever geometry tool you like, and because geometry is just one small part. We talked a lot about
It
the
is.
non-geometric
Yes.
semantics, and people
Yes.
keep on forgetting that it's um, a lot
Yeah.
of the
So
building is non-geometric.
your role. you work at Lend-Lease, right? So what stages of the design process do you work in? Because it sounds like you might work in the stages after the architecture design has been completed.
Uh, all stages, I think. So starting from early feasibility, concept design, design development, and of course construction and operations too. I'm very fortunate to be working for a company that has that kind of full stack approach, and with coming with that full stack approach is the expertise across all those stacks.
Yeah.
And I guess that's where IFC truly shines. Um, if you're just a one man show or working as a silo in a single company, the benefits of doing BIM in a structured manner, um, there's there's not much benefit. It's a means to an end.
There is from the automation perspective, like it's
A little,
still these
yeah.
days a little bit easier than hand drafting everything in AutoCAD, let's say.
Oh, I mean structured BIM. So structured open BIM. So for
So tagging
example,
everything appropriately.
yeah, and using the semantics that are standardized by ISO and are also cross discipline. Like, don't forget, a lot of our BIM models are a teeny tiny fraction, a sliver of the disciplines required to actually build that thing. Can you fabricate off your BIM models? Mostly not. Can you cost directly from the model? We're starting to get there. Can you schedule off it directly? Eh. Hidden. You can visualize a schedule in it maybe, but you wouldn't schedule off it. You see what I mean? Are all your assets really set up in your model? Not really. Are your building sensors really connected in that way? Do you actually have one model, or do you have 5 discipline separate models that geometrically look as though they're the same spot, but no, they're actually 5 separate models in 5 different projects, half of which they haven't even named the project name correctly. So who knows if it's the right project or not? So
Yep, sounds about right. You know, there's always like this challenge with working on larger projects, right? Because that's what we're talking about here. Essentially, it's larger
absolutely.
projects that require a level of sophistication, perhaps that's not needed on smaller, let's say, residential or single-story buildings. And in those projects, when the consultants come back, and we always have to do clash detection, right, to make sure that
Yeah.
plumbing, mechanical, wiring and so on, all these connections don't interfere, let's say, with the structure or with anything else, or they don't pop out in the wrong place. For example, a corridor, you wouldn't want your plumbing to be out there. So there's always that level of exactly what you say. We end up with a model typically from each of our consultants. And then it's usually our job to sort of package that and then send it off to somebody like Lend-Lease, who then take it on board and continue to develop it to for other items, for example, scheduling, right? Like 4D and all those things, which are outside of the scope of architectural design.
That's right. And
This podcast episode is sponsored by my Patreons on patreon.com/UHstudio. Thank you so much for your support, and with your help, we can continue to produce even more content like this. If you would like to help sponsor content like this, check us out on patreon.com/UHstudio, and you also get some perks like some behind the scenes files, some in-depth tutorials, and all the 3D files that are available from YouTube tutorials. And you can also get some discounts on courses available on UH Studio Academy.
for example, in Australia, at least, it's different parts of the world. For example, the architect might have a toilet in one model, and then the pipe would be in a separate model. And of course, there's no connection between the two, right? There's
Yeah.
no semantic connection between the two. It's not. So, and similarly, you'd have a piece of mechanical equipment that has air going into it, for example, but it also have electricity going into it. And of course, those are 2 separate models. And so it's not really an MEP model. And even within the MEP disciplines themselves, um, their BIM data is disconnected. I mean, and this is not at all specific to where I work. This is just a general industry observation in case my employer is watching here. Um, if you have air ducts, for example, they're most of the time they're nothing more than boxes that happen to look as though they're next to one another. But if you actually ask the box, hey, what are you actually connected to? And what's inside you? Is it air? What type of air? Is it supply air? Return air? Are you going that way or this way? Do you stop here? Is that an air terminal there? You'll get the wrong answer. What's your flow rate? Like it actually doesn't have that information because, of course, that information is simulated elsewhere. In
So can you
spreadsheet world.
define all that
In
inside of
IFC,
every
yeah.
kit of every part of mechanical ducts?
Okay. Well, firstly, I'm not a mechanical engineer, so
Yeah.
I might say some very silly things right now. But as far as that, well, the flow rate, you don't put it in every duct. It's calculated as a system as a whole, and then you can analyze it as a point, from my understanding. Um, so it wouldn't come pre-filled out with this is.
Okay, I suppose then that the other way to ask is, can you in IFC, what would you do? Would you tag each piece of kit as, let's say, supply or return, and then
Yeah, you
tag
would
which
have a
system it
system.
belongs to? Yeah.
Well, that would be the system. This would be a return air system. So you would have, just like, and this is not a new concept, right? Our existing tools have the concept of
Yeah.
a system or a group of elements loosely defined. It's just say these group of elements serve a common purpose. It's a system. That's step one, grouping them. All these ducts and louvers and registers and whatever and pumps are all part of the same um, distribution system. And that's step one. Step two, you have to know the connections. You have to say that this segment is connected to this fitting, which is connected to that segment, which is connected to this terminal, which is connected to this movement device, and so on. And IFC has those relationships, and our existing tools have those relationships. Then you'd
Yes.
also tag it with the type of substance. So, for example, is it a fluid? Is it a gas, or what's the other one, like electricity or things like that? And again, our existing BIM tools have this technically if people used it properly, right? There are ways that it knows you can plug a socket in here and not there, and it's only electrical sockets go here, not air ducts don't go into there, hydraulic pipes don't go. It's only electrical sockets go in there, and so those are the bits and pieces which make up the semantic relationships of a distribution system. And unfortunately, if you actually interrogate most service models nowadays, you won't find those relationships, or you'll find them and they'll be just utter mess. You can't trust them.
I'm gonna try to find more very obscure IFC properties to test your knowledge, because you seem to be also an IFC encyclopedia, Dion.
Well, yeah, I guess when you build software to do with IFC, you start learning it inside out.
Yes.
So
I have to say, I've looked at the documentation, and I find it, even as somebody who I consider myself fairly tech savvy, I find it very challenging, to understand we know the basics
yeah.
just from the exports and imports, right? You have a site. In the site, you put a building. In the building, you
Ooh.
put floors. You're
but,
already
but you
looking at me
don't. You
like,
don't actually.
no.
see, that's no. So, yeah. So I guess that's the issue. When people see IFC through the lens of an import-export, they see
Yeah.
a tiny, tiny fraction of IFC, which, yeah,
Hmm.
there's, what's the right word? Cargo cult? I'm not. Maybe that's the wrong word. Like they think that's the characteristic of an IFC, where that's not the fundamental character. It's a symptom of what
Okay.
you could find in an IFC. But look, it's
Interesting.
not anyone's real fault. I mean, the IFC documentation is a technical document, and um, that's not that's not a bad thing, um, because it's meant for technical readers, and it has a very specific audience. It's
Yeah.
schema designers. That's the audience. Schema designers. Like, even if you take the computer, like the IT industry, they're a bunch of geeks. Um, the proportion of that IT industry who are schema designers, who understand the jargon infested in schema design, is a small proportion. And of course, this is going for ISO standardization. And if you go for ISO standardization, there are certain rules which you follow, right? You try to adopt existing ISO standards. You don't reinvent the wheel. And there are certain formats which ISO expects you to follow, certain ways of structuring or writing things. And of course, being international, you have to write in a certain abstract way. You can't be too specific. That marks out a locale. So yes, it's a technical document, but generally you're not the correct audience for that. it's it's meant for schema implementers who then expose it in a much more user-friendly way um, to non-technical people or well, technical people of a different profession. And that's what we are. We're technical people of an architectural engineering and construction profession. I mean, look at architects, right? Architects read very technical specs. We know the building codes back to front. Um, and then
Not all of
the
us, but
engineer.
many of us, yes.
Yeah, many of us, yes, yes. Well, you'd hope, for example, the structural engineers know certain things back to front, and they read other technical guides, and um, and yeah, sort of because we're in the same industry, we can slightly digest like an engineer or an architect. Like if they cross paths and look at each
Sure.
other's technical spec, you can sort of digest, but it's going to be a hard read. So now you're talking about IFC, which is going across many disciplines, also jumping across a discipline to the kind of IT schema design. So of course it's a technical read. So don't, yeah, it has a specific audience, and yeah, I guess the import export hasn't done it too many favors either. In some regard, it's done a lot of great things in other regards, but certainly not in a comprehensive understanding of the spec capabilities.
It's a very insightful conversation. Thank you for that. Now I don't ever to look at the IFC schema again.
Well, I mean, we had the same thing in the BlenderBIM add-on because a lot of the BlenderBIM add-on, well, BlenderBIM add-on is a native IFC platform. So the buttons you see on the interface, the drop-down lists, it's auto-generated from the IFC documentation. So in fact, this is an interesting bit I should mention in case it wasn't obvious. The IFC schema is made out of two parts. The first bit is computer code. The actual IFC schema is computer code describing to a computer, here's how a digital building looks like. And so it's a black and white definition. There's a right way of doing IFC and there's a wrong way of doing IFC. Accompanying that computer code is uh, a thick book of of documentation, which you find online on the website. It's not a book; it's a website, which describes the intents behind the design of that schema. So, but there is an original intent, and so there's still it's slightly less black and white, but very very close to black and white. Of this is the correct way of using it. This is the wrong way of using it, or never intended to be used this way. So what the BlenderBIM add-on does is that a lot of its buttons and drop-downs are generated from the IFC code itself that's standardized by ISO. So if you say, I want to call this a wall, and you click on the drop-down list to look for a wall, that list of things you can pick from comes directly from IFC. And if you hover over that list, all the descriptions comes from that second part of IFC, that book, that ISO standardized book of descriptions of the intent. So if you hover over it, it'll say a wall is a da 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 da. So it gets all the useful little bits of snippets and exposes it to the user. So for example, once you created your wall, you say, I want to create a property. What properties can I assign to that wall? Well, here's a list standardized by ISO. Click on that one. Oh, one of the properties is fire rating. Great. Hover over it. A fire rating is defined as a blah, 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 and so on.
Okay,
Anyway.
so the best way to get familiar with IFC sounds like it's through BlenderBIM for
Well,
more
yeah, absolutely. Create IFC yourself.
practical kind of solutions, right? So you go in there and first, I suppose if you do bring in a model from somewhere else, you can look at the structure of the IFC a bit better, right? In BlenderBIM.
Yeah,
And
absolutely.
second, now are there, last we talked, I think you were just starting to create a wall tool, let's say. Are there more tools like a wall tool now to natively generate IFCs? Or is the scope of BlenderBIM still more of editing an existing IFC than generating from scratch?
Definitely the goal is to generate from scratch. So,
Oh, great.
yeah, so we've kind of got it from a short answer. yes, there's a lot more than wall tool now. A lot more. Walls, doors, windows, slabs, beams,
Right.
columns, stairs, roofs, spaces. It's there. Um, I guess there's this the development of Blender BIM. Firstly, it's shaped by the users.
Mm-hmm.
If you are a user using it on a real project, um, that task always gets priority. We try to solve that. Well, the first priority is whatever I'm using it for, right? Whatever the
Yeah,
developer is using it for. That's the nature of how it works, right?
of course. And
Uh,
do you use it a lot in your day-to-day work at Lendlease?
every day,
Every
absolutely.
day.
I don't think I could do my job anymore without it. It's yeah,
Nice. So that's an essential tool. And then does that mean that there are other people that are also using it in the company? Yeah.
absolutely, yeah. I mean, yeah. So on a lot of projects, we give it out the free tool, and we and because we use it in quite a few interesting ways that I don't think I'll go into a lot of detail here, but. Many consultants would also be using it to do particular tasks, and I guess we had the benefit that um, because I'm the main developer, I've built a lot of very custom little tailored extensions to it that can do certain things. But I mean, we're not the only large company using it. I would say a lot of the large AEC companies have picked it up and are using it in one form or another. I think there was a an article in AEC magazine about BlenderBIM being the BlenderBIM add-on being used on Hinkley Point C in the UK, the nuclear power plant. Um, so that's pretty
Wow.
exciting. Yeah. So I think I mean there are people using it in a kind of acupunctural way in on their projects. Obviously, not the end-to-end workflow, but little bits here and there, um, really depending on your company. Um,
I was a little bit curious, I suppose, for what you were saying earlier about the 5 different BIM models that come in after, an architect handoff to the developer. And Lendlease being a developer, I would imagine is, the type of company that typically has to sort it out and make a little bit more sense of it than what was described. So I don't know if you're allowed to talk about that, but it would be interesting to see if Blender BIM in some way has no proprietary information. All right. But I
yeah,
imagine then it's, maybe something like BlenderBIM could be used to handle some of that
yeah,
translation.
and so some of these are definitely a proprietary project. I can't speak about it, but the tooling definitely is not proprietary. So you'll see a lot of development occur um, as a side effect. So or bug fixes. So for example, the features to do with 4D and 5D costing and scheduling in the BlenderBIM add-on were heavily driven by my day-to-day work requirements.
Another exciting feature that BlenderBIM has recently gotten is documentation. Can you talk a little bit more about the capabilities of documentation in BlenderBIM?
Yeah, absolutely. So I guess one of the big myths in IFC is that IFC is a purely 3D data set. And we talked a lot about the non-geometric data and they're proving that wrong. But in addition, there's a lot of 2D data. And in fact, IFC 2x3 had quite an extensive suite of 2D drafting semantics that were included in it. And so this includes drawings and dimensions and text tags and fill regions and all that type of fun stuff. So you can do all of that in IFC, and so naturally we do that in BlenderBIM. And one of the things that are pulling the development, that's kind of, I like to think of it as there's two sides of the BlenderBIM development. One side is the 10% of the industry that does BIM, the 10% of that 10% which does OpenBIM, and then the 10% of the 10% of that 10% which does OpenBIM seriously. And that's kind of like in the top 100 AEC firms in the world, right? That's the little niche of people trying to do the holy grail of structured BIM data.
But that's how good things start in any industry, isn't it? It's from research and development, from like the boundaries of the professions. And then
Yeah,
eventually, if more people adapt to them, the tools get developed a little bit better, and then they become mainstream.
Absolutely, and that's certainly one way in which the BlenderBIM add-on's being stretched and pulled and used in these acupunctural ways. But the other end of the spectrum is the 80-90% of people, the 70% of the industry who still submits council drawings as hand sketches on napkins, because that still happens. Like I went on to
It
local
does.
count, it still happens. The people
Yes.
who are still in pure 2D land, who don't build 3D models, never mind semantics. Um, and
Yeah.
and and it's a bit of a mismatch, right? You hear these talk about digital twins and digital cities and all this type of stuff coming from governments whose local councils have still 80% of Bob's house done in a hand sketch, and that's where the reality bites. And so that's the other extreme that's pushing BlenderBIM. It's, can you do Bob's house? Can you do everything you need to produce your architectural sets of plans and get your construction certificates and so on, so that you can do Bob's house? And there's a simple set of MEP, a little bit of a structural simulation, small scale residential, small retail fit out type stuff. Can you
Hmm.
do that from scratch in purely free software, uh, like the BlenderBIM add-on and its little ecosystem of tools? That's the other push. And because at that end, these things are used as a means to an end, of course, there's a big push in getting correct drawings out. So getting plans, sections, absolutely. So yes, you can do that in the BlenderBIM
So
add-on.
you can do it now. You can generate, 1, 2 story buildings completely in BlenderBIM, documentation, door schedules, wall schedules, tagging, specking, and so on.
Yes, to a certain level of user friendliness, I might add. So
Mm,
that's the key bit. It's how user friendly can you get it? Um,
yeah.
I mean, for example, there's people willing to put up with a lot of pain. Like you can, in theory, 2D draft everything manually, and people do that, right? They do that. You
Yep.
get a good set of good hotkeys going, and you get some good music going. You can do that really fast, especially
I
in
and well,
residential design.
not only any design really, like when we get to that level of detail, construction detailing, even in Revit, with hand draftings, we don't want to spend the time to embed that level of intelligence in the model, because first off, it makes the model very heavy. Then it makes us spend a lot more time into defining each of those connection points, where if we have a typical detail that describes 50% of the situations, and then another one that describes the other 50% of the situations, it's much easier.
Absolutely, absolutely. So yeah, I guess there are certain levels of usability. So, for example, um, right, there was a point in time where I think when we last spoke, you couldn't just click a point and say create a space, create a room, and now you
Yeah,
can. You can click a point and you say
wonderful.
create a room.
Because believe it or not, that's such an essential feature
I know,
that
I know.
I thought I don't need it, because I tried on a private
You need
project,
it.
small project in FreeCAD last year, and the modeling in FreeCAD was great, but the documentation part of it was very painful, because anytime I change rooms around or the layout a little bit, I had to redo half of the documentation. And that's the point where
Correct.
I've come to appreciate even more from a BIM centric environment is maintaining those relationships, even if the geometry shifts around a little bit, which it always does.
It does. Yes, that's the fact. And so that's what we're always working towards. We're just making it less and less and less painful. And people and everybody has a different pain threshold. If you're a diehard, uh, you know, um, get your websites through email type of thing through a custom script. You've got a higher pain threshold, and then you've got lower pain thresholds. Anyway, so we're trying to get that lower and lower,
But we
and
don't want to scare anybody. I think it's a good point to actually try it, even if it's for small
yeah,
tasks at the moment, isn't it?
yeah, definitely give it a shot. It's still alpha software. And I have this definition of alpha in that it's not ready for Joe Bloggs to do his house in it. Beta means
Okay.
it's ready for um, it's ready for Joe Bloggs to do a simple house in it, and he can get by there. And this doesn't just mean code, by the way. It means that there's also enough documentation and training tutorials and all the rest of the ecosystem that you need. Um, and then finally, you get stable, where it's all right, guys, just switch now. There's no excuse anymore.
And is there some kind of roadmap of beta, reaching beta, at least?
I made a prediction that it would be last year. I was wrong. So I'm not going to make any more predictions. And
Yep.
I've been thinking to myself, what's the best way? I currently think maybe I'm not the right person to answer that. Maybe the community needs to answer that. Maybe I need to say, look, when there are 10 people doing regular commercial small scale projects in BlenderBIM, it's hit beta. You can do it.
Mm.
You just got to do. And 10 is just a random number I plucked off because, as you know, there's many silent users. Um, but that would be one way of looking at it. And so I've got a list of I mean, you're an architect. You know what goes into producing a set of basic council plans at certain stages. Early concept stage,
Yep.
you gotta have your dimensions. You gotta have your certain types of tags. You gotta have certain types of shed. Like you just mentioned a few of them. We've got that checklist, and we're just working through them methodically, taking them one by one. Um, it's just a matter of time, and that time is shortening tremendously. We're getting to beta faster and faster because there are people sponsoring code. There's people. There's extra contributors. There's people testing. I mean, you'd build something, and then within a day you get a series of people testing it. It's getting faster and faster and faster. So,
And you're getting faster and faster and faster at updating it.
well, no, we've actually fixed to a 2-month release cycle now. So
Okay.
there used to be a point where I released whenever I felt like it.
Yeah.
It doesn't scale. so now we've got a little Kanban board. You can see what we're working on for the next release. You can see what's been finished, what's still in progress. You can see who's been assigned to it. At every release, you can see the people who worked on it, the people who donated, what the funds went to, for example. So yeah, it's a 2-monthly release, but more and more things are happening in that 2-month period. It's accelerating.
And you mentioned other contributors, so other people are starting to contribute now to the code?
Absolutely. Yeah. So overall, there are about 138 contributors that
Wow.
have written some code in some form or another over the past 10 years. That's the thing. It's 10 years. But that's a long tail distribution, right? You get a tiny fraction of people who write code all the time. They're just churning out code. And then that drops significantly until you get it's just like a Wikipedia edit, right? A lot of that you get a lot of people who viewed Wikipedia but never touch anything. And then
Hmm.
then it's a sudden drop to the people who have edited one page on Wikipedia, but nothing else, and they disappear. And then it drops again and again. It's this exponential drop until you get to that series of core developers. And that's, I guess, um, the sustainability. That's the symptom of the sustainability of open source project. Are the core developers rising, or do you still have a very small bus factor? So I guess that's something we've been taking a very serious look at. Can we convert that long tail distribution into a series of core developers? Um, I count myself as a core developer, despite I'm not doing it as my full time job. Uh,
Hmm.
of course, we've gone this long talking without mentioning Thomas Kreinen. So he is the other core developer. He started IFC OpenShell. He's the man himself who knows IFC, backwards. He's another core developer. Um, and if you go to the IFC OpenShell website, you'll see a list of the core developers. You see their avatars, and that list is just generated by stats. Basically, if you hit a certain level, you're a core developer. Um, and we now have funding can sponsor um, uh, another developer. So we have since we last talked, we've had a newly sponsored developer who writes nearly as much code as me, uh, or actually, I think in this next release, he will be writing more code than me. Um, so yeah, it's growing.
Fantastic. And who's sponsoring the development?
Currently, we've got about 80 something, almost 90 sponsors. Um, the majority are individuals chipping a bit here, a bit there. We've got a few companies as well, and just like the list of developers, if you go to the IFC Open Shell website, you will see the list of those sponsors. Should I show that on my
Okay.
screen, or is this the audio section?
This is the audio one, the audio version.
Okay.
So, but we can say where it is. So, if you want to contribute to BlenderBIM, where would you? Let's start again. So, if you want to get started with BlenderBIM, what's the best place to get started? Do you just download the software from blenderbim.org and then you start playing with it? Are there some examples maybe that people
Yeah,
can,
that's right.
that people can
So
test?
if if you are the end user who wants to build graphical BIM stuff, go to blenderbim.org. It's got 4 pages on the website, so you're not going to get lost. It's got a home page, got a lot of cool pictures on that. Got a download page, that's where you download it. It's got a community page saying where you ask questions, find bugs, and and give us money if you want to. And the final page is the documentation. And if you click on the documentation, the very first thing which will show you is a YouTube playlist, which is a series of videos done by the IFC architect, who has done an excellent job of describing, how to install it, how to draw a simple floor plan, how to load up an asset library, how to do a simple two-story building, for example, and create some drawings out of it. He'll guide you through that process, and that's an excellent series of tutorials. I mean, I've written a lot of the code, but I tell you, I watch his tutorials and I'm learning things. Like, wow, you can use it like that? Hey, that's really cool. So it's an excellent video series. And of course, for those who don't like video, there are some text tutorials in there, which are not as developed because it takes time to write text. And the video series may be slightly outdated, but because we move so fast, but it will get you there. And that's the best way to do it, I'd say. Follow those video series, have a play. There are
And if
some
somebody has
tutorials.
questions or,
There's a
or
forum.
just some general comments, is there like a forum place that you would recommend?
Yeah, that's right. So if you go to the community page, which is one of those 4 pages we just talked about, there is a community forum, which right now it sends you to the open source architecture community, so you can just chat over there. There's many other users over there. There's also a live chat that's also part of the open source architecture community, so you can just ask and receive questions in real time. You can share your screen if you have a troubling issue. Um, there's also a place to submit bug reports. Um, yeah, so quite a few channels
Great.
in there.
So for those that are not familiar, open source architecture, the website is osarch.org, and it's got a community. I think is the most essential part of it. A lot of it is based around Blender BIM as well, and some topics that are stemming off of Blender BIM. Like there's a new feature that Bruno is incorporating right now, right, which is a Git using IFC with Git, right? So you can push and pull specific data, which is essentially, I believe, what Revit does, isn't it?
Well, no one knows for sure what Revit does. It's a black box.
It's
But
true.
uh, yeah, I know. So Revit follows a kind of, would you say centralized? It's sort of centralized. Now that I think about it a little bit more, I'm less certain. Maybe it's less centralized than I thought it was.
It's
Um,
distributed. Like there's a central model. It
hmm,
works exactly like GitHub. So you have like your central model. You duplicate. You create a clone on your local hard
yeah.
drive. You save it, and then sometimes you synchronize it, which is exactly like pushing to the main.
Yeah. Yeah. Well, tell you what, maybe that will be an excellent thing to discuss with Bruno, who is the developer of the Git integration with IFC. I'm sure He will have a lot of
Yeah, we
insights into
actually
that.
had a chat, but it was more on homemaker and understanding like where that came from. And before that, there was a chat on topologic, which are coming up. Well, by the time this is out, all those podcast episodes should already be out.
Right, excellent. Well, maybe another chat with Bruno then, because it's a fascinating topic.
Definitely.
It's something that needs to be solved in our industry, and there's a few ways to slice and dice it. And one day it will be solved, and that will be a very good day.
Great. So we did it last time. We had a conversation, and then you jumped on and showed some of the basic BlenderBIM functionality. And I thought it might be a good idea to do the same this time.
Yeah, absolutely. We can do that.
Thanks so much for watching this episode. And as mentioned, there's a part 2 available on YouTube where Dion takes his hands-on with a tutorial. And as mentioned, thank you so much to all my patrons for sponsoring this content. Your support means a lot. And if you'd like to become a patron and sponsor more content like this, check out patreon.com/UHstudio.